This machine is the impact test for the impact test. For using it, you have to put your sample here and align it in the center, and then put the needle in 264, and then you release this crank, and the way it is released, then this crank impact the sample and breaks it, and then you have to return it to its original position.
The type of fracture that we got with the material 1018 was ductile at room temperature, and when it was at minus 14 degrees it got brittle. For the material 1045 at room temperature it was moderate ductility, and when it was at minus 14 it got also brittle.
Impact resistance is the ability of a material to hold, to support load applied to it.
The main applications of the hardness test, we can use it in forging industry, rubber industry, and plastic industry. They are applied for knowing the force applied for the malleability and ductility of the material.
The ductile brittle transition temperature is a temperature where the material stops behaving like a brittle one and starts behaving like a ductile, or a ductile material starts behaving like a brittle one.
P test is different of the ISO test. Why? Because the tube is larger. When you put the test on if you're going to do the Sharpie test, you have to put the tube horizontal. If you're going to use the ISO test, you have to put the tube vertical, and the tube has to be larger.
The rupture of a metal into two pieces. On this practice, we're going to analyze the brittle fracture and the ductile fracture. First, the ductile fracture is this is one example. Here you have a plastic deformation. It means that the material can resist more stress until it breaks. And here we have the brittle fracture. And this you have the material, the broken material, and it just breaks like this and doesn't have a plastic deformation. This means that a ductile deformation can resist more stress.
When you're doing the impact test, the steel that is going to break more cleaner is the one that has more carbon, because the carbon covers up the steel better, and it makes the steel less ductile.
This test is a very useful test in our real life because you have to know if a material is brittle or not, or ductile. So you have to make this test to little specimens of metals and at different temperatures, so that you can know exactly the behavior of the material that you will use for a part.
I like this practice, but I hope that we can make more impact tests, not only the one with the hammer. I would like to know if there are more tests or more ways to do it, because I think that is like a quickly practice.
While doing the impact test, we can see more clearly the way the temperature affects the material. Since with the material that was really cold, it was a different rupture than the one that was at room temperature. So it is really important to test really the materials and prove that the temperature actually affects them.
I think the impact test is very important because with this you can test the material you're going to use for a specific application, and also you can know if it's going to develop correctly changing the temperature, because as we saw in the practice, the ductility of the material changed if we change the temperature?
It's really important to know how to use this machine, because if you put your steel in the wrong way, the impact test is going to go wrong and you're not going to be able to define what you are looking for.